A sorted array, with some values repeating. Strip every duplicate without borrowing a second array. Where would you even start? Take 0, 0, 1, 1, 1, 2. The unique run hiding inside is 0, 1, 2. We want exactly those, left sitting in place. Here's the real input, 0, 0, 1, 1, 1, 2, 2, 3, 3, 4, sorted with every run of repeats clumped tightly together. 5 distinct values live in there. 0, 1, 2, 3, 4. That count 5 is the number our function hands back. Now the twist. We don't return the values themselves. We return 5, and the first 5 slots must already hold those values in order. Anything past them is junk the judge ignores. First instinct. Walk the array, push each fresh value into a brand new list, and skip anything you've already seen. That list fills up with 0, 1, 2, 3, 4. Right values length 5. Honestly, it looks finished. Then read the judge carefully. It never inspects your shiny new list. It checks nums itself, slot by slot, against the answer. So a separate array can't save you. The original has to carry the answer inside its own front slots, not somewhere off to the side. And that extra list eats memory that grows right alongside the input. Our real target is to do this with 0 extra space. Back up. One property of this array is still completely untouched. It is already sorted. Sorted carries a consequence. Equal numbers sit shoulder to shoulder. Every duplicate is a neighbor, never scattered far across the array. So spotting a repeat is cheap. Compare a value to the one just before it. Equal means it's a duplicate we can ignore. You might reach for deletion. Slide everything after a duplicate one step left. But each slide rescans the whole tail, and that stacks up into n-squared work. Don't delete. Overwrite. Keep a marker for the next place a unique value belongs, and stamp the keepers forward into the front. That's the two-pointer move. Picture 2 fingers resting on the array. One finger reads ahead, the other marks where the next unique value gets written. The read finger visits every single element. The right finger only steps forward when a genuinely new value shows up. And compare each read against the last value you actually wrote, not its raw neighbor. That written value is the true edge of the uniques so far. Set the right marker to index 1. The very first 0 is automatically unique, so it stays locked in slot 0. Read at index 1, value 0, the last written value is 0, equal. Skip it, and the right marker doesn't budge. Read at 2, value 1, the last written value is 0, different. Stamp 1 into slot 1, then advance right to 2. Read at 3, value 1, it matches the last written one. Skip it, right holds steady at 2. Read at 4, still 1, still a match against the last written value. Skip again, nothing gets written. Read at 5, value 2, the last written value is 1. Stamp 2 into slot 2, and right climbs to 3. Read at 6, 2 again, matches the last written 2. Skip, right stays parked at 3. Read at 7, value 3, the last written value is 2. New, stamp 3 into slot 3, and right becomes 4. Read 8 is 3, a match, so skip. Read 9 is 4, brand new. Stamp 4 into slot 4, and right hits 5. The read pointer runs off the end. The first 5 slots now read 0, 1, 2, 3, 4. Return 5. Notice what just happened. Nothing moved twice. Read crossed the array once, right trailed behind stamping keepers. No spare array, no shifting tail. Read touches each element exactly once, so the time grows straight in step with the array's length, nothing worse. And only 2 integer pointers exist beyond the input. The memory stays flat no matter how long nums gets. Code time. The first element is always a keeper, so the right index starts at 1, one step ahead. Run the read pointer from index 1 across every remaining element in the array. At each step, compare the current value against the last value we actually kept. When it differs, copy it into the right slot and push the right pointer one step forward. When the scan ends, right already holds the count of uniques. Hand it back. Sorted plus 2 pointers. One reads, one writes, and the array repairs itself. Keep that pairing in your pocket.